creating a function. So that's what we want to do today. So in Python, a function is defined using the word def keyword. So whenever you see def, let's copy this, run a function. So you can see now, this is a function. A function that is defined. The function is defined, and you know the the function is defined, and then you can see. Let's run it. Let's see what comes out. Now, note that nothing happened. But then let's see if let's see now. As you see now, you discover that when I first run it without calling the function, because this is how to call a function. When you write a function and you just print it, it wouldn't respond because it's not. Then until I call the function, this is the name of my function. My function, that's the name. Then when you put two brackets, it means you called it. Do you get the what we told it to print? We told the function printed. All right. So I did now. We just call the function. Is that we want to look at what we call arguments is information that can be passed into a function. That's what we call a function name inside the parentheses. You can add as many arguments as you want. Just separate them with a comma. So the following example has a function with one argument, f name. When the function is called, we pass along a first name, which is used define. So def, let's assume that's defined. Function, that's the name of the function. Then this is an argument right here. And then we now say print this plus this. So let's see what happens. So remember, we've passed in an argument, which is first name. So we're now saying that, okay, whenever the function is called, anything that is put here should be printed plus this. So let's see what happens here right here. Let's try the first one. The what we have here is to call the function. Remember that the I have those two parentheses, but then you can see f name. So the f name we now passed in is now Emil. That's the first name. F name. Did you see? Emil. Then he added this one to it. Do you see now? So meaning that right here you can see that we define the function, and the name of the function is my function. We open our parentheses, we pass in an argument called first name. We now say, okay, please print is. Let's close up the space. Let's see what happens. Let's see what happens. You're supposed to just concatenate it and jam pack it together. Let's see. Because we added a space, a character called space cannot be shifted aside from our last class as any other character. The space was added as a what? As a character. Like as usual, we already said that space is important in Python. So, and then that was how we got that space, right? So, of course, yes. All right. So, like I used to say, once you come on, just always like it, like Jim can help us suggest it to these our people. Right. So let's rerun it, and then you see it gives us the space again. So now what happens if I change this to Bolade? What happens? I just lost this. Now let's assume that I change this to Adeyemi now. Adeyemi. What do you think will be the output of this function? Somebody help me. Somebody type. Somebody guess what will be the output when I've changed in my function. I added Adeyemi and then of my function. I want to know if we are following me. Bola Adeyemi. Yeah, thank you. But then there will be a space. Thank you, Okweya. So let's see, and boom. Do you see now? So of course there's a space because I added a space here. Now, first name, let me say last name. Look at this, last name, and then let me say, so I don't even now need all this again. I can just say print first name plus last name plus this, right? So, but then,
So numbers of argument. By default, a function must be called with the correct number of arguments, meaning that if your function expects two arguments, you have to call you have to call the function with two arguments, not more, not less. So I also said that the last time that once you say first name and last name, it has to be first name and last name. To not answer you if it is not first name and last name, which is so you can see this is what it prints. You print out the first name, then space, then the last name, right? So we have to make sure that it's not less, not higher, right? So let's print this. Let's see. Python, then script.py, and then let's run it. You can see. So it's only take we define first name or define last name. So and then we have to put in first name and last name when calling it. Okay, so if you try to call the function with one or more arguments, you will get an error. One or three arguments. That is, if you say if it is not two, you go and use one, you go and use only one. Even the system will be complaining that why are you using one? Right? Let's try it. Let's let's see what happens when I use one. Do you see? It says my function missing one required positional argument. Last name. Do you see now? So when you type only one, it assumes just the first name. And then you can see. So it will not answer you. All right. Let's go ahead. Arbitrary argument. Arbitrary argument. Okay. So arbitrary argument says if you do not know how many arguments that will be passed into your function, add a asterisk before the parameter name in the function definition. So this way, the function will receive a tuple of arguments and can access the item accordingly. Okay, so we've not really talked about tuple, but tuple is just like an array that can store kinds of information. It can store more than one data, right? So that's what they mean by to receive a tuple of arguments. So for example, if the number of arguments is unknown, add a asterisk before the parameter name. So look at it. My function will have kids, you can see. Then the youngest child is plus kids. You can see, like, very interesting. Let's see the output of this. See the output of this. VS Code. Let's clear the screen. Okay, so let's see the output of this. So, you can see the youngest child is Linux. So you're the one that we decided the one. So we said actually kids. You can see. So on a normal day, it will not even run because we only inputted, assuming we did not put asterisk and we just say kids, then it did not answer us because we are calling it with 3. So that's already wrong, right? So, but because of the asterisk, it allows multiple. So it means that we can even add Bolade, you see, to never make a complaint, because we have already said that it should be expecting an infinite number. Do you see? Still did not change. So to now select Emily, you already know that when we try zero, should select Emily, right? Let's try. Should we try? Let's see how it looks. Mhm. You see, the youngest child is Emmy. To select Bolade now, what do we do? Uh, 0, 1, 2, 3, 4, right? 0, 1, 2, 3, right? So your guess is as good as mine. 3. Once I say 3, then that is exactly what is going to go and choose the third one. And then boom, the youngest child is Bolade. Do you see that? So that is very interesting, isn't it? All right, so let's move on. Okay, so I hope so far been getting it, getting the subject of discussion. And like I used to say, uh, so anytime you see this, just make sure that they are not subscribed. You can make sure you subscribe and also turn on the notification button, notification bell, so that every time every time I make a stream, you can get a notification. You won't have to uh, be wondering where the link is, right? So you already notify you, and then of course you can give this video a like, right? So, right, that's just the least you can do, right? So let's go ahead. Um, let's go ahead to uh, so you can see it said arbitrary arguments are often shortened to asterisk hags in Python documentation. So yeah, that made sense, right? So very interesting. So keyword arguments. You can also send arguments with the key equals value syntax. This way, the order of the argument does not matter. All right, let's see. Key value syntax. Let's see what's going on here. So you can see the the define my function child 3 comma child 2 comma child 1. So then print the youngest child is child 3. So my function child 1, child 2, child 3. So you can see now. So we defined, we talked about three arguments here, but in the function we only referenced one, right? So the other we only reference child 3. Child 2 and child 1 has not been referenced. All right. So now calling the function, you can say child 1 equals this, child 2 equals this, child 3 equals that, and then obviously child 3. So we should be expecting lineups, right? So let's try see what happens here. Let's see it's lineups. Okay. So if I say child 2 now, you already know that it's Tobias we're expecting, right? Let's see. And boom, you see that. And then the other one. So Relix works so good. So it means that inside the call, you can say this equals this. So you can see. So you can say this equals this equals this equals that. All right. That makes a lot of sense, right? So the phrase keyword arguments are often shortened to KW args in Python documentation. So We keep telling you about Python documentation because there's a documentation and you can actually learn more from Python. Like I said earlier, as a DevOps, you need to understand Python because it's very useful. We would find where to stop on this class, but then there are so many other things. I'll drop a material on the WhatsApp group. I'm going to drop that material, and the material is going to let us the material is going to show you some of the things that DevOps did with Python. Earlier on, we've already used Python um, to rename a file. We've done a file operation on Python. That is one job Python will do for you as a DevOps. So there are other things Python can do for you, like reading files, you know, appending files, updating files. These are operations that Python can do for you as a DevOps. All right, there's so many you can read about. So, but then I'll just continue from here. So let's go ahead. It said arbitrary keyword argument. That's KW hacks. If you did not know how many keyword arguments that were passed into your function, then add two asterisk, right, before the parameter name in the function definition. So this way, the function will receive a dictionary of argument and can access the arguments accordingly. Example, if the number of keywords is unknown, add a double before the parameter name. Add a double. Okay, for example, it says if the number of keywords is unknown, add a double uh, asterisk before the parameter name. Let's see. Let's see what happens there. You can see there's a double asterisk here, right here. And now say his last name is plus key there. And now say last name. And then you can see, very interesting. You can define a parameter up and then come to, or is it an argument? Now it's not parameter, it's an argument. You can do uh, kid, then you say you can do asterisk kid rather, and then you now say print his last name is plus key then last name. So you tell the Python which of them to select, and then you now come here to define. So it means I can still say middle name, right? Say middle name equals to, of course, separated with a comma, right? So I will say middle name equals manual. So right, so it doesn't change a thing. Let me So I can now define the one choices. But then you already know that what you're expecting is his last name is reference, right? So reference, right? That's what we're expecting. So you can now come here and say his middle name is. Then you come here, say middle name. You see, very interesting stuff. Let's clear this and then let's run it. You can see the middle name is Emmanuel. That's very amazing, isn't it? So that's keyword args. Right, arbitrary keyword args arguments are often shortened to keyword args. So we said is a beyond time in this video, so let's just continue. Default parameter value. The following example shows how to use a default parameter value. If we call the function without an argument, it uses the default value, right? So for example, let's try just one of this. So of course, if you did not uh, give it a value, it will use if you call it without an argument to give it a default value. So normally it says if we call the function with an argument, it uses default value. Okay, so now look at this. If I say, after saying the function country is Norway, print from then plus country, look at what happens here. Let me show you something now. Look at what happens here. It says I'm from Sweden. You can see he used the value of the argument, of the new argument. There was one that was defined earlier. You can see country equals Norway. So, but it uses this one now because it is the newly defined value. So now, okay, so now let me not use anything here. You'd see what it will say. And boom, I'm from Norway. You see now. So for this, once you did not define anything here, it will help you use the one you have defined. Yet you can still define. That's the interesting part. That's in Nigeria. Yet you can still define. And then there's this, and then boom, I'm from Nigeria. You can see. So very, very interesting, right? So passing a list in an argument. So you can send any data type of argument to a function. You can send in a string, you can send in a number, you can send in a list, as a dictionary, etc. So I would want us to go and read more on lists and dictionaries because we've not been able to treat it, and I don't want us to keep, I don't want us to go one more class on Python. I want it to be that, okay, if you have something you want me to teach about, of course, you can let me know in the comment section whenever you watch it. So let's see, and it will be uh, treated as the same data type inside the function. So, e.g., if you send a list as an argument, it will still be a list when it reaches the function. Okay, let's try this. Let's see. So, of course, this is a list. The list right here is like an array, and then it says define my food. My function is food, yeah, and then now say for x in food. Remember our for loop for x in food. What this does is that it will loop through the food one by one, one by one. So now say fruit equals what? Apple, banana, and cherry. Now say my function fruit. We have, this is a parameter right here. This is the food, is the argument, and this is the parameter right here. It's a parameter defined here. So let's see what this outputs first. Let's see what's going to happen. You can see it's looped through the parameter. So we already said that we're going to put a parameter called food, and then in for x in food, right? For x in food, x, it doesn't necessarily have to be x, but we'll just use x. Can say for foods, I can say for foods in food, and then I'll say food. So it's not necessarily that is x. So you can say for foods. I don't know if this make any sense. For foods, or you can say, to make it more good, you can say for items in food. Let's say items. So, but at the end of the day, what happens is that it loops through every items of the food and the print item. So, we always want to use descriptive name, like we said, whenever you're using Python. Make sure that always try as much as possible to use a descriptive name. Always try as much as possible to use a descriptive name so that you don't get confused at the end of the day as to what you're trying to do, right? So you can see says uh items in food. So what all just know that when you say for something in something, it loops straight, and that is exactly what's going on. So now we said the argument is going to be food, right? Food. And then we now said that in the function, whenever it loops through, it should print the items. So it is what is inside that food that it will print. So we now say fruit is equals this. So you can see. So we define the food. I will put it in a dictionary, and then and answer that my function is what fruit. So you can see it really making a lot of sense. You can now say, uh, let's say, let's say, let's say pasta, right? Then you see, then you can say spaghetti. It's interesting, isn't it? And then you say fusilli, right? So, and then you can come right here to say pasta. So it loops through it, loops through it, and then it's very, 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 very amazing, right? So you already know what we're expecting here, right? Or are we expecting to loop through the pasta, right? And boom, it loops through the pasta. So that is very, very interesting, right? So we need to get that also. And then return value. To let a function return a value, use the return statement. We use the return statement. So return will return a value. Return we do what? We return a value. So let's see. Return value like this. You see, define my function x, then return 5 times x. So and then print my function, then this. So this is the value of x. So 5 times 3 should be our answer. So we're expecting 15. All right, so let's try it. Boom, 15. So we say 10. So we're expecting 30, right? So let's see down, it's 30. Boom, 30. So I think we understand. So return value is to tell Python what to return. So a function can use a return statement. Function can use a return statement. Let me try another one. You can say rating. You can no, you can say name. You can say name, and then right here you can say return. You can return a string that I'm trying to demo here. You can return a string and say hello, hello. Then we use that space for a gap, and then you say name, right? You see that, and then you can come to say here Bolade. So that is the name. That's the name we're passing across, right? Let's see if that runs. Let's see. It says Bolade is not defined. Okay, let me see. Let me see why it's saying it's not defined. This is it. This is supposed to take an argument called name, right? Let's see. Supposed to be supposed to be defined. Okay, so okay, so let's just leave this. I don't know why it's not, why it's saying not defined, but then we can obviously be able to, supposed to be able to return this, right? We're supposed to be able to return this. Okay, let's see something like this. Let's see. Normally it's supposed to bring this, but it looks like the name Bolade is not defined. Look like it's tied to the keyword. Let's say name equals string. Oh, okay. Now I get why it's not responding. Okay, got it now. So the problem is that when we said name, I love when things like this happen. The problem is that when we said name, we did not we did not come to tell it the kind of character to expect. We did not come to tell it the type of character to expect. So, you could look at it, I said name equals of string name. Let's see if this runs first. Oh wow, the problem is fixed. You can see hello Balade. So the thing is, when the function was defined, I said it's going to get it gets an argument called name. And then here, I'm supposed to say the kind of argument that we are expecting. I'm supposed to say name equals maybe string or integer or something. So, and then I will now return hello, then the name, right? So, but well, the important part is that you got that the return works, returns gives you, return tells the function what to the final value, and then the print will output it out, to call it, right? So that makes a lot of sense if you ask me, right? So you can see we're just able to do that now. So let's move on to the next one. The pass argument. Function definition cannot be empty. But if you, for some reason, have a function definition with no content, put in the pass statement to avoid getting an error. You can see whenever you have a function and there is that is empty, or that has no content, you can just say pass, right? So pass will actually uh, do the job, right? So let's just move on. Position now only argument. You can specify that a function can have only positional argument or only keyword argument. Specify that a function can have only positional argument, had had comma, forward slash after the argument. Let's see. Define function. So of course it's going to just output 3, right? So but then the what we're trying to establish is that you don't want any other thing, that comma, this comma, forward slash, uh actually allowed to use keyword argument, even if if you remove this now, it will be allowed to use keyword argument, even if the function expects positional argument. Right? Remember we talked about keyword argument, where we keyword argument up there. Let me show us again. This is keyword argument where you can say this equals this, this equals this. And the positional arguments are the ones we have been using, where you just say first name, last name, middle name, all those stuff like that. First name, comma, last. So this is positional argument. This positional argument. So, but then, uh, if you define a function, you can define a function. You can actually make sure that the function cannot take in any other value apart from positional argument. So you say x comma space forward slash, it will not take in a key argument. Like I cannot now say number equals to, let's see what happens there. Like it doesn't even know. Got an unexpected argument. Do you see? Got an unexpected argument. Number equals to, right? So that is exactly what we're talking about. Okay, let's see. Do you see now? Like this is a keyword style. When I said something equals something, it's a keyword style. So you can see that it did not accept it. It's refused. But then if I just say this, it's not going to. If I just say 3, it's not going to give me any headache anymore, because that was owing to the of this space and forward slash, that already defined there, right? So let me see. Uh, you see now? This is that the same thing that I did now. I said x equals 3. Like I said, I already said this is a keyword star. So the same thing that I did now. Remember, I just wrote x equals 3 now, and it gave me an error. The same thing did not give me an error now, because I did not specify. So these are the things you should know. You can see, as soon as I specify, as soon as I say that, oh, it's only positioner that I want, and then this, see what happens now again. It's going to tell me that, bro, what are you doing? See, it says my function got some positioner only argument passed as keyword. Do you see now? So you can see it doesn't work. But then when I remove the positioner only, I can always say, I can always use any style that I want, and then boom, it works. I use any style now. All right. So I hope we got that. Um, okay. So um, we've demoed that. We've demoed all this. We've demoed all this. So keyword argument only. You can say, oh, it's keyword argument only that you want. To specify that a function can only have keyword argument, you can add asterisk before the argument. So let's try this. So you can say asterisk is something like this, right? You can say asterisk. So now this time around, it will only allow keyword arguments. Now if you print this, it should work. But if we now say 3, Let's see. Let's see what happens. This you know. The function takes zero position argument. This you know. So and one was given. You cannot use positional argument for this. This you know. So you can see how Python can be stringent based on what you defined in it. So this is a keyword argument specified, and then you cannot use a position argument like this. It has to be something like this keyword argument, and this is the only time to answer you. You can see, let's print down, and then boom, three comes up. Do you see? So if you ever specify, then you have to follow through with what you specified, except you did not specify. If you did not specify, it will take it whether positional or keyword, anyone works. Okay, so let's continue. Uh, we know all this already. We've done all this. We already said that if, but with this, you get an error if you send a positional argument. We said that. So combining positional only and keyword only. We can combine two arguments type in the same function. Any argument before this are positional only, and any argument after this are keyword only. You can see very interesting stuff. See this, these are positional, these are keywords. I can reiterate that these are positional. A, B are positional. You can see they don't have to say A equals this, B equals this. But these C, D are keywords. You must say C equals something, D equals something before you get a value. So let's clear, then let's print, and then 26. So look at what I'm saying. These ones now, they are positional because you already said that A, B, then space forward slash, that's positional. So it assumes 5 is A and B is 6, right? But this, so let's assume I did not define anything here. See what happens. You can see if I did not, if I just write, if I just write 7 and then 8 here, let's see what happens. If I just write 7 and 8, let's see what happens here now, right now. So if I just write 7 and 8, let's see. Do you see? So it says takes two positional arguments, but four were given. So the only argument that we define is this A and B, right? A and B. Those are the only argument that we define. But and then we, for position, remember, those are the only argument defined for position. There are two, and they were now writing four positional arguments. Yes, you know. So Python will get confused. Python will be like, where are the two where are the two keyword arguments, right? So then until now say, oh, C equals this, and then D equals this, then Python will now say, oh, okay, now I've seen what you what I'm expecting. You can see that. So now another thing we cannot do is, let's see, A equals 3. Let's see what happens here. B equals 8. Now you still get an error, obviously, because it is still expecting you to, Python is still expecting some argument, right? You see now. So it says my function got some positional only argument passed as keyword argument A and B. Do you see? So if you are now trying to convert A and B to keyword, it is still not answering. So of course, you already know how it's supposed to be. You should see this should be compulsory, and then you would get your answer now. All right. So that is it about that recursion. So this will be the last thing I'm talking about on the. This should be the last thing. Let me see. Yeah, the last thing. Recursion. So let's trying to see how we can, you know, finish up function, and that's exactly what I'm doing. Python also accepts function recursion, which means a defined function can call itself. See, recursion is a very nice concept in programming that almost every programming language uses. In programming, the recursion means when a function calls itself. Inside the function, the function can call itself. The function can do, like, it can use itself inside itself. I don't know if that makes sense, but then let's try. Recursion is a common mathematical or programming concept. It means that the function calls itself. This has the benefit of meaning that you can loop through data to reach a result. The developer should be careful with recursion, as it can be quite easy to slip into writing a function which never terminates. Do you see now? Because it will keep calling itself and calling itself and calling itself. So, or one that uses excess amount of memory or processor power. You see? So it's you can, if you are using, you have to be sure of how to use recursion, so that you don't go and type that is the caveat to it, so that you don't go and uh, do a function that will keep calling itself and calling itself and calling itself and never stop calling itself, right? So let us uh, take note of that, uh, and then say that, however, when written properly, recursion can be a very efficient and mathematical elegant approach to programming. So in this example, try recursion is a function that we have defined to call itself recurse. So that is, it calls itself, right? So we use the k variable as data, which decrements each time we recurse. So the recursion ends when the condition is not greater than zero, that is when it is zero. So it is a new developer to a new developer, it can take some time to work out how exactly this works, but best way to find out is by testing and modifying. All right, let's quickly check this with caution. Like I said, this is the last thing we're doing on function. Now look at it. It says define try recursion, try underscore recursion. If you remember, this is snake method of naming something. So that's snake naming convention. So we said that recursion takes in a value called try recursion takes a value called k. So that's a if k is greater than zero, if k is greater than zero, then the result equals k plus then try recursion k minus 1. If k is greater than zero, the result we are expecting is k equals try recursion k minus 1. K minus 1 means any value that is written there. So if 6 was written, it's going to be k plus try recursion into 5. So 5 will now be what will be here. So that's a print result, else result equals 0 and return results. So the way this recursive, so you can see inside this function, you still called the function. You are using the function inside itself. That's a very sweet part. That's how sweet recursion is, right? So let's try this. Let's see what happens here. Let's see what happens here. Do you see? You see what happens? It says if k is greater than 0, right? It said result equals to k plus. Now, look at it. What's the value? What's the value of our k? Our k is our k is 6, right? If our k is 6, that will be 6 plus 6 plus yeah 6 plus 5 minus 1. That's what 6 plus 5 minus 1. That's what 6 minus 1. That's 5. So k plus. So whatever happens here plus, then we do it again with this. Do you understand? And then you can see the 1, 2, 3, 4, 5, 6. The stuff starts. You can see it started incrementing. Do you see? It started incrementing, and then it did it. It gave us how many results? 6. Let's try. Let's try another one. Let me say 8. And then let's see what happens. 8. You can see 1, 2, 3, 4, 5, 6, 7. So it gives out eight eight values. It produces 8 values, right? So to get more understanding of what's going on here, let's copy it. Let's ask the ChatGPT. So these are one of the things that can really assist us, right? So we can get more simple recursive stuff. So I think we're done with this. We don't need that anymore. Let's see. ChatGPT should explain this. Let's break it down. What it does is a recursive implementation of triangular numbers where t of n equals n plus t into n minus 1 with t not t greater than 0, right? So calling it try recursion, 8 computes 8 plus 7 plus 6, like that, like that, like that, like that. So it takes it step by step. Try equation 8 calls try equation 7. Equation 7 calls 6, like that, like that, like that, which till it finishes up till it gets to 0. You can see that what is happening. So then the results are returned back up the stack. You can see try equation 1 equals to 1. Remember k plus k minus 1, right? Let's look at it again. K, which is, let's say 8 plus k minus 1, that's 7, right? So now look at this. 1 plus this 0 equals 1, print 1. Calculation 2 says 2 plus 2 minus 1, which is 1, which will now give us 3. So you can see 1, 3. So I'm trying to let us see how this stuff is calculated. So it's not just that computer is suggesting a random number. It is it is based on what we have said that it should do. And that is exactly what it's doing for us. So you can see for the try equation 3. So these are this you can see all these steps happened inside the block of code, right? But it's not visible to us. That's why I had to bring it here so that I can really explain, right? So you can see try recursion 3. This gets called, and then 3 plus, you can see 3 plus 3 equals what? 6. You can see try recursion this. You see, very interesting. Then it keeps going, it keeps going, it keeps going, it keeps going till it gets to the last one. So if you want a further explanation on recursion, you can always explain, right? So it says the function recursively calculates the sum of all integer from k down to 0 It keeps decrementing it. Because remember it says -1, so it will keep till you can see it says else result equals 0, return result. So we're saying that once our answer is 0, if we did not put this caveat there, it will keep running and running and running forever. To keep running because we did not tell it to stop. Once you say return means that stop. That's where you should stop. Do you understand? So, but if we did not put this caveat that when result is 0, return this, you know what we're about to do? We're about to run into a state to just keep calling itself forever, to keep reading, keep reading, keep reading until I close my VS Code. It will keep reading on. So, that is a powerful thing about recursion. That's why we said that we have to really understand what you're trying to do until you do it. Until you have to understand what you're trying to do so that you can do it properly, right? That's what I mean. So it said the print result shows the intermediate step after each recursion call is complete, and the final return value is 36, although it's not explicitly printed after the call. If you want to display the final result, modify the last line. So you can say final result equals this. So all right, so that's it. So I just need to stop here, right? So I hope that we've been following, and I hope that we really understand what we have been trying to say. So function is very interesting. Every other part that we have not been touched, when you read, of course, you can always come to Web3 to read schools, web3schools.com to read about Python, right? So when you do your study, any part that is not clear, you can always say, "Oh, I have a part that is not clear. I have this part is not clear." If you have something that is bothering you, talking about Python, some of the things that are on this video I do not understand, you can always drop it in the chat box or in the WhatsApp. You can drop it on YouTube chat box or in the WhatsApp group. And like I used to say before I go, if you're watching this video, you should the least you can do is to subscribe and turn on your notification bell, right? So let's do that so that we can always flow with the channel. All right. So saying that, that will be the end of the Python basics for DevOps. And trust me, it's been an amazing journey. And like I usually say, that you can be a DevOps without Python, but you would be a better DevOps with the knowledge of Python. All right, so we'll continue the next amazing topic on this cloud computing journey in the next class. I hope that we really understood. Let's please enjoy the rest of our time or our day, wherever we are. All right. Thank you so much, everyone. Thank you for watching. Let's have a nice time.